Alright, so what we're dealing with today as far as our graphs goes is we are going to talk about some different key features on our graphs. So I have up here all the definitions of them, and I could sit here and read through them, but it's kind of boring when you do that. So we're going to actually go through the examples. So if you take a look at the pictures of the three graphs that I have given you here, these are three of the main graphs we need to know this year. Who remembers what kind of graph A is? Parabola. What's our other name for it too? Quadratic. So this is our quadratic graph. Does anybody know what graph B is called? Absolute value. And then our third one, graph C, that's our linear graph. So these are the three main graphs you have to be able to know. Yep. We have a lot of other graphs we're going to be doing this unit. We got exponential graphs, we got square roots, cube roots, piecewise defined step functions, a whole bunch of them we're going to do. Yay. So what I like to do is I like to start with the end behaviors, because those are some of the easier ones. If they ask you for the end behaviors of a graph, all they're asking you is which direction is the left and right side of the graph going. So if we look at our quadratic, our left side of our graph is pointing which way? Down. So we would say left side down. Which way is the right side pointing?
Down.
Right side is also pointing down. So how about for our absolute value graph? Which way is our left and right side pointing?
Up.
Those are both pointing up. So left side's pointing up. Right side is pointing up.
Down, up.
And then our last one, our linear one, yes, our left side is pointing down, but our right side is pointing up. And that's all you have to do for your end behaviors. Tell us which side we're looking at, left side, right side, which direction is it going, up or down. So next, let's go to our domain and range. We've dealt with domain and range a little bit before this year, but we're going to go over it again. Domain are your x values. Range is your y values. So when you look at your graph, you kind of have to ask yourself, are you going to be using all of your x values, or will you be using all of your y values? So let's take a look at our quadratic first. Because it has arrows, that means it keeps going on forever. Will it eventually use every single x number? Could it keep working its way out to the sides and use every single x value? Yeah, it's going to take a while, but eventually will. So since it will use every x value, we use this notation for it. X, that's a little funky E, and the double R there. What that stands for is it says x is an element of the reals, which means x is every single value possible. So if we look at our absolute value, again, just looking at your x as your domain, is it going to keep working its way out to the sides? Yeah, and it's going to keep going on forever. So again, it's going to use every x value. So x is an element of the reals. You're going to use everything. How about for our line? Will it keep going and use every single x value? Yes. So again, x is an element of the reals. I'm going to give you a hint. Your domain is always going to be x is an element of the real, with the exception of one type of graph we're going to do in a few days. So if it's got arrows on both ends, x is an element of the real. It uses everything. Let's write that up here to refresh our memories when you go back to look at these. Means uses every number. XER means that it uses every number. Yeah, it's a special kind of E. Stands for element. So let's take a look at our range values. Now the range doesn't always work out as nicely as the domain does. The range is a little more difficult. So again, we are looking at our y values for our range. So you're looking at your y-axis there. So with our quadratic, we have this little turning point up here. Will my graph ever be higher than that turning point? No. So it's going to be everything lower than that. So when it's lower than that, we use a less than or equal to. So y is less than or equal to. And what is this value up here? 4. If I look over at my y-axis, that's at a 4. So y is going to be less than or equal to 4. Now if we look at our absolute value graph though, again, we've got a turning point here and everything is higher than that turning point. So which symbol do you think we would use this time if it's going up? Yeah, going down was less than, going up is going to be greater than. So y is greater than or equal to. What's our lowest y value? 0. When it's on the axes like that, it's a 0. So y is greater than or equal to 0. And then our linear is different. Isn't it going to keep going up and down forever? It'll eventually will use every single y value. So this one's going to be y is an element of the reals. That one will use every y value. All right, so we're going to do increasing, decreasing next. So with increasing and decreasing, what you have to do is you have to follow along the graph. So you start on the left side of the graph and you follow the graph. Which way is my graph going, up or down? Up. So this side of my graph is increasing. Stephanie, put your phone away. Left side of my graph is doing what? I'm sorry, right side of my graph. I said that wrong. That side is decreasing. So my quadratic has both increasing and decreasing. How about my absolute value? This one starts decreasing first, and then the right side of it is doing what? Increasing. And then for our line, what's that one doing? That one is increasing the whole time. So you got to be able to figure out when it's increasing, when it's decreasing. You always start at the left, and you work your way over. So the way that we write this is right here for our quadratic, the increasing and decreasing switch when x is negative 2. So since the increasing is to the left of negative 2, we say x is less than negative 2. That's when my graph is increasing. When it's to the right, it's greater than. So when x is greater than negative 2, our graph is decreasing. Let's see here, this one's at 1, 2, that's at 3. So we're decreasing to the left of 3, so that's going to be when x is less than 3, our graph is decreasing. And it's increasing when x is greater than 3. Your inequalities can kind of help point you in the direction for that also. Now for our line, we said it was increasing the whole time. So we're just going to put a little line through decreasing because that graph's never decreasing. Since it's always increasing, you rate it just like your domain. X is an element of the reals. It's always increasing. All right, and then our last part, positive, negative. You're positive when you are above the x-axis. You are negative when you are below the x-axis. So looking at my graphs up here, if we shade it a little bit, This part of my graph is positive, everything above my x-axis. So when I shade that in a little bit, my quadratic, it has some positive parts, but it also has some negative parts. Is my absolute value ever negative? No, that's entirely up in the positive region. And then how about our line over there? We got some positive, right? And then we got some parts of it negative. So for this one, I'm going to do my absolute value first. As we said, the whole thing was positive. So when it's always the whole thing, it's x is an element of the reals. The whole thing is positive up there. That one is never negative. If we look at our line, it switches from positive to negative right here when x is 0. So when x is over here greater than 0, it's what? Positive. So when x is greater than 0, that one's positive. It's up in my shaded region there. So then my negative has to be when x is less than 0. All right, and then our last one, our quadratic. I skipped that one because it's got a little trickier there. So from when it's negative 4 to when it's over here at 0, so negative 4 to 0, that whole part of the graph is positive. So the way we write that is the smaller number is less than x, which is less than the larger one. You always have to go smaller to larger. Always going to be a less than sign with your x in the middle when the graph is in the middle like that. So from negative 4 to 0. So then it's going to be negative when x is less than negative 4. So that's saying this part of it over here is negative when x is less than negative 4. Or when x is greater than 0. That's this part over here. So I find it's usually the writing of it that's a little trickier than actually understanding when is it positive, negative. So on the back of this, we have some sample questions of how they like to ask about positive, negative, increasing, decreasing, all that good stuff. So let's go take a look. So our first one there, we have f of x equals 1/3 x plus 9. They're looking for which statement is true. So what I want you to do right now in your calculator, type that into your y equals so we can actually look at the picture of the graph. You can use that one. That one will work. So 1/3 x plus 9. I want you to look at that in your calculator so we can look at the graph of it. Does your graph look kind of like that? Hopefully. Okay, so let's take a look at this. I like to change these f of x all to y's because you guys are usually better when you're dealing with y's. So we can go ahead and change those all to y's. It makes it a little easier for us. So they're asking, is y always less than 0? Are these y values up here less than 0? No. So that one's not our answer. This one's asking, is y greater than 0? Our graph does kind of look like it's greater than 0, but if I extended this graph, wouldn't it eventually go underneath 0 and be less than 0 also? Yeah, so it's not that one either. I didn't mean to cross that out there. So if x is less than 0, then y is also less than 0. So here's my x is less than 0. Is my y less than 0 up there? No. So this one ends up being choice 4. When x is greater than 0, y is also greater than 0. You've got to go through your different choices there. Two, let f be the function such that f of x equals 2x minus 4. Over the domain, 2 is less than or equal to x, less than or equal to 6. The range of this function is, again, let's use our calculator. Type that into your y equals. And let's get our table of values. We just want to go from 2 to 6. So when your y equals, you're typing in 2x minus 4. So if we look at our table, again, they told us to go from 2 to 6. So where x is 2, what is our y value? 0, and then 3 is 4, 5, and 6, 8. Bless you. So which range goes from 0 to 8? Choice 1. There we go. All right, number 3, using the graph below, would you characterize the interval -5 to -1 as increasing or decreasing? Explain your choice. So again, this is from -5 to -1 in your x's. So I'm going to count over to -5, 1, 2, 3, 4, 5. My graph is down there at -1, so it starts there. And it goes to where x is -1. So just this part of the graph, is it increasing or decreasing? Increasing. How do we know it's increasing? Because it's going up. So it says give one additional interval over which the function is increasing and one over which it is decreasing. All right, so let's find another increasing part. Looks like from here to there, it's also increasing. Is it increasing anywhere else? No. So let's figure out what that is. My first point is where x is what? 2, and then it stops where x is 5, 3, 4, 5. So it goes from 2 less than x less than 5. 2 to 5. Now we have 3 decreasing parts we can pick from. We got here, here, or there. So really any of those are going to work. I'll pick this one in the middle. It goes from -1 to +2. -1 to +2 is our decreasing part. Again, there's 2 other parts you could have had on there. I just picked that one. Then our last one, using the graph below, find the values of the domain for which the function g of x is less than 0. Again, let's change that to y because it just makes it a little easier. We're looking for when y is less than 0. So that's this part of the graph down here. That's when we're less than 0. So what's this x value over here when it starts entering the less than 0? -5. And what's this over here when it leaves the less than 0?
Oh,
+5. So it goes from -5 to +5.